Surface area of prisms. The surface area is the sum of the areas of all outside surfaces of a 3D figure. To find the surface area, you must find the area of each surface of the figure and then add them all together. If we look at this picture over here, what type of figure is this? Well, this is actually a rectangular prism. How many surfaces are there? Well, we have a top, bottom, left, right, a front, which is talking about this part, and we have a back, which is parallel to the front, but back here. I'll do that one in green. This is referring to the bottom. So there are a total of 1, 2, 3, 4, 5, 6 surfaces. So how do you find the area of each surface? Well, they're all rectangles, so you're going to multiply the length and width of each rectangle together and then add them all up. And here we see the answers to these questions, and they do match what we found. We have a rectangular prism. There are 6 surfaces, and in order to find the area of each surface, you multiply each face's length and width together. So when we do calculate the surface area of the solid, we break the area formulas down into special pairs. At least this is one strategy. So you could find the area of the bottom and the top, which is 8 times 3, and you would have 8 times 3 on top and get 24 square inches. And then you could multiply the left and right together, which is 3 inches by 6 inches, and get 18 square inches. And then you can multiply the front and back to the length and width of the front and back together. So you'd have 8 inches times 6 inches, which would be 48 square inches. And then if we add all of these values up, we find that the sum or surface area of the solid is 180 square inches. Another way that you can visualize the entire surface and calculate the surface area is to create a net of your solid by unfolding it. So we have this rectangular prism with a length, width, and height, and if we take the 2 sides down and unfold the top, we would get the top all the way to the right, which is length times width. Then you would have this right rectangle with width times height right here. You would have the front and back going in their respectable directions and have length times height as the numbers that you're multiplying together. Then you would have the bottom in between there, and then you would have the left side come down to the left. And similar to the right side, its dimensions are width times height. And once the net is unfolded, you can calculate each rectangle's area. So this left side, we have 3 inches times 6 inches, which is 18 square inches. The back has dimensions 8 inches by 6 inches, or an area of 48 square inches. The bottom is 8 inches by 3 inches, which has an area of 24 square inches. The front is identical to the back, 48 square inches. The right side has an area of 18 square inches, and the top, unfolded down, matches the bottom and has an area of 24 square inches because we multiplied 8 and 3 together. And then if you add up all of these area values, we still get the same solution, 180 square inches. Find the surface area of a rectangular shoebox that has a length of 12 inches, a width of 6 inches, and a height of 5 inches. And here's a diagram that is shown. And And here's also what it looks like if we were to unfold it and create its net. So first, let's look at the top and bottom. So our top and bottom have a length of 12 and a width of 6. So we can write this down 2 times, one for the top, one for the bottom. And when we multiply 12 and 6 together, we get 72 square inches. All right, now we got to look at the front and the back. So our front and back are these 2 rectangles. We have here, it would be 12 inches times 5 inches. And that's going to be 60 square inches. And we can write it again because one represents the front and the other one represents the back. So those that we found, the 60 is here and here. And we found the 72 for, again, the top and bottom. All right, and now we have to do the left and right sides. These 2 rectangles here, which can also be represented by these 2 rectangles in our 3-dimensional solid. So we're going to multiply 5 inches by 6 inches, and we're going to get 30 square inches. And if we do the same thing here, we'll get the same answer, 30 square inches. And then to calculate the entire surface area, we are going to add all of these values together. So we have 72 plus 72 plus 60 plus 60 plus 30 plus 30. And when we add these values up, we will get 324 square inches. And here again is the correct work that's required in order to solve this problem. It does match the solutions that we had calculated when we worked this out together. The only additional step that was taken here is that they added 72 and 72 together to get 144, added 60 and 60 together to get 120, and added 30 and 30 together to get 60. And then they added those values up and still got 324 square inches. Does anyone see a pattern with the area values that were found? Can you find a shortcut to solve this problem a little bit more easily? And how would your shortcut make the problem easier to solve? Take a moment to pause this video and think about these questions, and when you're ready for the solutions to these questions, unpause it. If we look at the area values that were found before they were added together, we see that, well, we have 2 that are identical, and their area is equal to length times width. We have another area that can be calculated by multiplying the length times the height, and there are 2 of those, the front and the back. And then for the left and the right sides, we can multiply the width and height together each time. So using variables, the surface area of any rectangular prism can be calculated using the surface area is equal to 2 times length times width plus 2 times length times height plus 2 times width times height. Let's try another. Let's name the figure and then find the figure's surface area. Well, what we have here is we have a rectangular prism. And that tells us that our bases are indeed rectangles. And then we can find the surface area of this figure by determining what each area is and then adding them all up. So let's start by finding the top and bottom areas. Let's call 5 meters our length and 3 meters our width, and we'll call 7 meters our height. So for the top and bottom, we would have 2 of them, and their areas are 5 times 3. And if we multiply these values together, we will get 10 times 3, which is 30. So 30 square meters is the combined area of the top and the bottom. And now let's look at the front and back. And notice that the front and the back are the same, so we can put a 2 in front, and we can multiply our length 5 times our height 7. And when we do that, we will end up having 10 times 7, which is 70 square meters. So again, that was for the front and the back. And now let's look at the width and height, or the side rectangles. So for our side rectangles, again, we have 2 of them right here and here. And we have 3 meters by 7 meters. And when we multiply these values together, we'll get 2 times 3, which is 6, times 7, which is 42 square meters. And then to calculate the entire surface area of our figure, we are going to add these 3 values up. So we have 30 plus 70 plus 42, which will be 142 square meters for the surface area of this rectangular prism. And on this slide, we have the solutions to this problem. It is indeed a rectangular prism, and for the top and bottom, the combined area is 30. For the left and right, the combined area is 42, and for the front and back, the combined area is 70. So if we add up 30, 42, and 70, we indeed get 142 square meters, which was the answer that we had calculated when we worked through the problem together.